Now that we've looked at the molecular cellular mechanisms of learning and memory at the neuronal level, we're going to step back out using that modal model for memory and start focusing in on long-term memory systems. We'll start by discussing declarative or explicit memory systems. We'll talk about their general properties, and then we'll talk about the two kinds, semantic long-term memory and episodic long-term memory. Then we'll turn our attention to non-declarative or implicit memory systems. We'll talk about what they have in common, and then we'll look at the specific systems, the procedural memory system, priming, associative memory system, both emotional and skeletal, and the non-associative memory systems. And we'll finish by looking at a video that illustrates the dissociation between declarative and non-declarative memory systems as a result of bilateral hippocampal damage. So long-term memory refers to a number of systems having two information management functions. First of all, these memory systems act as filters for information entering into long-term storage. These systems act as filters in three senses. They specialize in the sort of information that they encode. They determine how that information gets encoded, and they help to select what information actually gets encoded. The second information management function of these long-term memory systems is that these memory systems also perform the management function of coordinating those molecular processes we discussed earlier for the purposes of storing memory structurally in the brain. Long-term memory systems also exhibit two familiar information-based functions. Some systems function as relatively static information stores, and some systems function as relatively stable mechanisms for reconstructive processes. In all cases, long-term memories last for a much longer period of time, often, though not always, for an indefinite period of time. In the next slide, I'm going to give you a full taxonomy of memory systems for human beings. Now, this is a lot. You might freak out when you see it, but the main distinction that you need to know is between these declarative and non-declarative memory systems. So let's take a look here. So we have these two different classes of memory systems. We have the declarative memory system, which is also called explicit memory, and we have non-declarative memory systems, also called implicit memories. So when we look at declarative memory systems, our memory for events is facilitated by the medial temporal lobe and the diencephalon, and it's referred to as episodic memory. Memory for facts, or semantics, that is facilitated by the hippocampus and is also considered declarative memory. When we look at non-declarative memory, we have a number of different systems. On the one hand, we have procedural memory, which is strongly associated with the striatum. We have priming and perceptual memory, which is strongly associated with the neocortex. We have simple classical conditioning, which can be broken down into two separate kinds of conditioning: emotional responses, which is facilitated through the amygdala, and skeletal responses, which is facilitated through the cerebellum. We also have non-associative learning that is facilitated through the reflex pathways. So, declarative memory systems for events and for facts are associated with the medial temporal lobe and the diencephalon. And here, this rotating skull here shows you the, on one hand, hippocampus, and on the other hand, the diencephalon. When we look at the long-term memory systems of the brain and focus in on the hippocampus here, it looks sort of like a seahorse. And the hippocampus runs along here. The amygdala is at one end, and it has projections to the prefrontal cortex, to the unimodal and polymodal cortex, and down here to the temporal lobe. Declarative memory systems share a common functional characterization and a significantly overlapping neural substrate. At the functional level, researchers consider declarative memory systems to be representational and to encode factual information about people, places, things, times, as well as the significance of such information. Though they're not necessarily propositionally encoded, normal subjects can express information stored in declarative memory through linguistic or graphic mediums with sufficient precision to warrant its evaluation for verticality, most often whether or not it's true. Declarative memory systems encode information from many cognitive systems in a manner which is both associative and versatile in its application and in the elicitation of those stored memories. So, for example, your semantic knowledge about coffee can be elicited by the sight, smell, and taste or abstract thought of coffee. Likewise, you can use your knowledge about coffee to make decisions, solve problems, or explain why Wallace has a headache because of caffeine withdrawal. Encoding of declarative memories depends upon conscious attention and occurs relatively quickly in many cases. Recall also requires conscious effort. Declarative memory encompasses two widely acknowledged systems. These systems were first differentiated by Tulving into the semantic and episodic memory systems. Semantic memory encodes factual and conceptual information in a relatively objective, that is, context-free, and atemporal, non-chronological format. Episodic memory differs from semantic memory and all other memory systems in that it encodes personal experiences for retrieval through echophoric autonetic chronesthesia. Autonesis refers to conscious self-awareness, whereas chronesthesia refers to conscious awareness structures through one's subjective temporal metric. In other words, episodic memories are re-experienced as one's own experiences in the context of one's own past, present, and future. Episodic memory is at least partially dissociated from semantic memory in cases of semantic dementia. Professor Elizabeth Warrington in 1975 first described this progressive aphasia caused by the degeneration of the anterior temporal cortex on the left hemisphere. People who suffer from semantic dementia exhibit increased difficulties with identifying objects, concepts, and people, as well as accessing the names of these objects, concepts, and people. Nevertheless, these people generally speak with grammatically correct and fluent utterances. At least in some cases, semantic dementia results in this dissociation between semantic memory and episodic memory. People who are suffering from it, at least some of them, still maintain a relatively good episodic memory, though their semantic memory becomes severely impaired. This isn't true for all people, but it is significant enough to provide one of the evidential bases for differentiating these two. They're also different in terms of the qualitative nature of remembering. Episodic memory involves reliving experiences if they can be declared, and hence it's included as part of declarative memory, and they're mediated a lot by working memory. In contrast to that, though, semantic memory is much less qualitative in its recall. And so the consensus among researchers in memory is that these are two different memory systems, even though they are closely related to each other.